Okay, students, so next is question number 6. So what it says, show that the line segments joining the midpoint of the opposite sides of a quadrilateral. So quadrilateral I have taken ABCD, okay? ABCD, and what they have said, show that the line segment joining the midpoint. So suppose the midpoint of this side is this side is this side is this, and this side is this, and I have named this PQRS. Okay, so they have said the line segment joining the midpoint of the opposite side. So you can see this midpoint and this midpoints are opposite sides, so I have joined this one. So this is the line segment joining the midpoint of opposite side. This is the line segment joining the midpoint of opposite side. Okay, so show that the line segment joining the midpoint of the opposite sides of a quadrilateral bisect each other. You have to show. So this line segment bisect each other. Bisect each other means this will cut this line into two half, and this line will cut this one into two half. Okay, so this and this equal I have to show, this and this equal I have to show, mean bisect each other. Okay, now how we will show that one? Now see here, this are the midpoint. This is the only information I have. So if this is the midpoint, then midpoint theorem might help you, right, finding this. If I join this one, see here, to show this one bisect, if I can show this is parallelogram, if I join it, this, why I'm saying parallelogram, the reason is midpoint is given, and through midpoint theorem what you can show, remember, line parallel. So through that theorem, if I can show that this quadrilateral which is forming by this 4 points, midpoints, if I can show this is parallelogram, then you know in parallelogram diagonal always bisect each other, right? So this proof we have done in class 8 also. So in parallelogram diagonal always bisect each other, we know that one. So we will show PQRS is a parallelogram. Okay, so how we will show that? Now see here, I have to show this and this parallel, right? And you can see this is the midpoint, right? And this line, if you can show parallel to a line, say I will draw from here diagonal. Can you see how I'm drawing the construction? It may not pass from the midpoint, okay? At this point I mean. Just draw. Now see here in this triangle, this and this is the midpoint, and this is line joining this midpoint. So we know midpoint theorem that in a triangle from two sides, if you select midpoint and draw a line segment, that line segment will always be parallel to the third side. This is the two side which we have taken midpoint, okay, and we have joined this line. So this line will be always parallel to the third side in this triangle. We know this and this parallel. Similarly in this triangle, this is the midpoint, this line will be parallel to this. So if this and this parallel, this and this parallel, can I say this and this parallel? Can you see how I am finding the solution? First, what I have done is I have seen there is a midpoint, okay, and I know that I have to show that this line bisect each other. Now bisect this each other means I will try to show this parallelogram. Now how I think about that one, that I will show this one parallelogram, the reason is you have midpoint theorem in which says that joining the midpoint of two sides always will be parallel to the third side. A line segment joining the midpoint of two sides of a triangle, you have a theorem. Line segment joining the midpoint of two sides of a triangle always parallel to the third side. We have this theorem. Okay, so this line I can show it is parallel to this one, okay, using that theorem, and this line parallel to this. Now if this and this parallel, this and this parallel, I can say this and this also parallel. Similarly you can see this and this I have to show parallel. What you will do, draw another diagonal here like this. Okay, now you know this and this midpoint, line segment joining the midpoint of two sides always parallel to the third side. So this and this will be parallel. Similarly this and this parallel, so this and this also will be parallel. So you know pair of opposite side, if it is parallel, it is a parallelogram. So in parallelogram we know diagonal always bisect each other. So very simple question actually, if you know how to analyze the diagram well. Okay, now whatever I will write here is based on whatever I have understood from the diagram. Same thing which I have done here, I will write down those things. Okay, so this is how you need to practice. You cannot practice directly by looking at the statement which I will write here. Okay, so first what I will do, I'm going to name this one first, right? Name is not given. Let A, B, C, D be a quadrilateral in which P, Q, R, S are midpoint. I have drawn midpoint, right? This one. I've named it PQRS, so I have to mention everything. Whatever is not there in the question, you always have to mention what you are writing. Okay, so midpoint of sides AB, BC. P is midpoint of AB, Q is midpoint of BC. Like that, you have to write, right? Midpoint of sides AB, BC, CD, and DA respectively. Okay. Okay, so I've mentioned the midpoint also. Now let us join P, Q, Q, R, R, S and PS. Let us join this one. So we have joined, right? Now we will show that PQRS is a parallelogram. Now how we will do that? Again, for that I need diagonal, right? First let's use this diagonal AC. Again AC be the diagonal. Be the diagonal of quadrilateral A, B, C, D. Okay, everything what I am writing here is from the diagram. Now we will start proving this parallel to this parallel to this, right? So we will select this triangle. So in triangle ABC, what I can say, P and Q are midpoint of two sides. Which two sides? AB and BC. Therefore, PQ parallel to AC. Why? Midpoint theorem. Okay, so I have already shown PQ parallel to this one. Similarly, SR parallel to AC, which implies, okay, you can mark this one as 2, this one as 1. Okay, so from 1 and 2, what I can write? PQ and SR parallel. From 1 and 2, from 1 and 2, PQ parallel to SR. Can I write? Yes, PQ parallel to AC, SR parallel to AC. So obviously this two also must be parallel, right? So I have already shown PQ parallel to SR. Now I will show QR and PS parallel. So same way, draw diagonal BD. So let us draw diagonal BD. Okay, where, okay, in triangle, now I will select this triangle, right? In triangle BCD, Q and R are midpoint of sides BC and CD. BC and CD. Therefore, can I write QR parallel to BD? QR parallel to BD. So, how you got this? Midpoint theorem. Right? Similarly, PS parallel to BD. Okay? PS parallel to BD. PS parallel to BD. So from this you can mark this one 3, this one 4. From 3 and 4, 3 and 4, can I write? QR parallel to PS. This might look answer lengthy, but see, when you understand things, automatically you can easily understand this portion also if you understand the diagram well. Okay, and does not matter with the length. If you understand, you can always write down this one easily. Okay, so QR parallel to PS. Okay, so therefore, okay, since PQ parallel to SR and QR parallel to PS, since PQ parallel to SR and QR parallel to PS, so can I say quadrilateral PQRS is a parallelogram? Therefore, PQRS is a parallelogram. Okay, and in parallelogram we know, diagonal bisect each other. So therefore, which diagonal we are talking about? PR and SQ bisect each other. Okay, PR and QS bisect each other. Okay, PR and QS bisect each other. Okay, that's it.